Hello everyone, I am Aryan Sharma and today's topic of presentation is real-time synchronization of Google Maps in app with Google Earth in Liquid Galaxy rig. Before going into technical detail of this, I want to first explain what this is and why it is needed. The presentation is about real-time synchronization between Google Map running on the mobile phone and Google Earth running on the Liquid Galaxy rig. In simple word, whatever I see or do in the Google Map in mobile app, such as moving, map, zoom in, zoom out, the exact same view get reflected on Google Earth in real time. In end of this presentation, you will completely understand how do we make this feature. The most important part of this feature is that it improves the user experience. Now user can control the Google Earth in Liquid Galaxy rig directly from the app. This is my app running in Pixel 6a emulator. This is I made for demonstrating this feature. As you can see, Liquid Galaxy Rig is completely synced and you can see it is synced properly with three other slave machines. First we go to the settings tab. As you can see in home tab, we move the Google Map. It is not currently synced with the Google Earth. It is not reflecting any change, or we zoom out anything, nothing happening. Let's come to setting tab. Let's enter the details. 1 3. Let's enter the password and connect. As you can see here, connection chip is changed to connected and it's go to the Spain its default location. Let's come to the home tab. Now you can see, as you change move any or the here it synced properly. Unzoom, it unzoom also. If we zoom to India, it is synced. Let me see you more clearly. If we zoom to India more, it slowly go there. If we zoom to more, it go, and we increase the zoom, it go to the this location. As you can see, now it is synced properly. As we move the map in the mobile phone, this get reflected on the Liquid Galaxy rig Google Earth. This is the river, you can see. This is the same you can see here. We change location, it is changing. Unzooming is working perfectly. Yes, this is basically all the main feature of syncing the Google Earth and the Google Map in the mobile phone. And as you see, this is the basic setting page. This is complete demonstration of the app. After the feature demonstration, now let's understand how the code is done. First we see the file structure of the app. Inside lib folder we have main.dart file and screen and service folder. Inside screens we have map screen.dart file, setting screen.dart file. Inside services we have lg services.dart file. Next, before coming to code, let's see which packages used for this app. Let's see pubspec.yaml file. The first and most important package used in this feature is Google Maps Flutter. This package provides the official Google Map SDK for Flutter, allowing us to embed a fully interactive Google Map inside the mobile application. I use this package because the entire synchronization process starts from the mobile side. The user interacts with the Google Map by zooming, changing the viewpoint. This allows access to real-time camera movement events such as position change and ideally state. In this feature, Google Maps Flutter is responsible for capturing the latitude, longitude, and zoom level. Whenever the user interacts with the map, these value from the data is used for syncing the maps with Google Earth running in the Liquid Galaxy rig. Next package is Dart SSH2. This package enables secure cell communication directly from app. Liquid Galaxy rig system typically accept commands over SSH to control Google Earth programmatically. To send camera movement command from the mobile app to Liquid Galaxy rig, a secure and reliable communication channel is required. This is where Dart SSH2 become essential. Here Dart SSH2 is used to stabilize a secure connection between the mobile app and LG rig. Through this SSH connection, I send KML based command that instruct Google Earth to move its camera in real time. Next package is HTTP. The HTTP package is used for handling network communication using REST based requests. Some interactions, such as triggering updates or managing services, requires lightweight and fast network communication. It helps in managing external calls without blocking the main UI thread. This ensures that the app remains smooth while synchronizing happen in background. Then after this we have shared preference. This package allows the application to store a small amount of persistent data locally on the device. In app, it is used to store connection related information so that the app can quickly reconnect to the LG rig. Last package is path provider. The path provider package is used to access commonly used storage location on the device. Some operations such as handling temporary files or storing generated KML data require access to device file system. This ensures compatibility across platform and proper file management. Each packages here was carefully chosen to solve a specific technical requirement, and together they form a complete pipeline for real-time synchronization between Google Map and Google Earth in the Liquid Galaxy rig. Now let's come to the code explanation of this. This code is make a controller for Liquid Galaxy rig. It acts as a bridge translating your mobile 2D map movement into 3D navigation commands for a multi-display panoramic system. First we have map screen.dart file. Let's start. In standard bottom navigation bar setup, especially when paired with the indexed, stacked or page view, the parent widget manages the children. When you switches from home map to setting, the framework marks the home widget as inactive. Usually this leads to the dispose method being called, which clears the map's memory and the Google Map controller. By adding the automatic keep alive client mix in, you are implementing a client server relationship between the child map screen and the parent, the navigator viewpoint port. The mixin provides the underlying boilerplate to communicate with the Keep Alive server, an inherited widget provided by Flutter's scrollable or stack based view. It ensures that the state object of your map screen is preserved in elementary even if it is removed from the visual widget tree. Then they want keep alive getter. This is an explicit signal to framework overriding this getter to return true. Create a keep alive handle. Memory persistence. As long as this return true, the state object is keep alive. This means your variable like last camera position, we will see this later, and the native Google Map view are not garbage collected. Without this, every time you switch back to map, the Google Map would have to re-handshake with Google server and LG rig. With this, map remains warm in the background. Requirement of super.build context. This is code. When you use this mixin, the most critical technical step is calling super.build context. Inside your build method, in Flutter internal source code, super.build is where mixin actually checks the want keep alive property. If it is true, it calls update keep alive, which attaches the widget to a bucket in memory that prevent it from being unmounted. Let's see if we do not use this mixing class or the difference with when we use it. First, we see the widget state. It is without when using mixin, it is disposed or destroyed. With mixin, it deactivated, paused in memory. With respect to Google Map API, re-authentication or reload tiles without mixing. With mixing, stay rendered and ready for when we come back. Variable persistence, last camera position variable reset to null. In with when we are using mixin, last camera position hold last value. The user experience is more good when we use mixin because it is immediate and seamless transition. Without mixing, it may flicker on the tap switch and it restart. This is the main difference when we use this mixing class and when we not use this mixing class in the page. We have some variables: LG services, last camera position. LG services, this is a custom service layer that handles the SSH connection to the Liquid Galaxy rig and sending the KML command and other works. Last camera position, it is a memory variable. It stores coordinate of the map every time you move it. Camera position, this is the default starting point. Next, we have very important function. This function basically converts the Google Map zoom into Google Earth range. As Liquid Galaxy use Google Earth, which thinks in range, distance from the ground, Google Maps thinks in zoom level 0 to 21. 591657500.5 is this is a mathematical constant representing the Earth's circumference. Zoom is logarithmic. Every time you zoom it by 1, you are seeing half the area. This calculate the raw altitude. Zero point 0.7, this is a calibration factor specific to Liquid Galaxy to make the phone view match the big screen field of the view. Dot clamp, it is a safety feature to prevent the LG from crashing into the ground minimum 50-meter or flying into the deep space maximum. I think it is 1 crore meters. This is all about the zoom to range function. Basically, it is a mathematical function that helps to convert 2D zoom into the range. Next, we have sync to LG function. This function is a command center of application. It acts as a translator that takes the mobile map and convert it into a format that Liquid Galaxy rig can execute as a movement means KML. Inside the function, first we have safety gate validation. Before doing anything, the code checks two things. Is their data? If user had not moved the map yet, last camera position might be null. Trying to read coordinates from nothing would crash the app. Is rig ready? If the SSH connection to the LG rig done? If not, sending any command would be waste only. This prevent the app from taking talking to a deep system. Then we capture the user intent or do the data extraction. This code extract 5 key variables from the Google Map. These represent the view the user is seeing on the phone. Latitude and longitude, the center of the map. Zoom, how close the user is to the ground. Tilt, the view angle. Bearing, the compass direction heading. The coordinate transformation. Here using zoom, it finds the range by using this function, zoom to range. Perform a mathematical conversion so that the zoom on the phone looks like range on the screen. Next, we have a very important thing as KML look at tag construction. Here, as LG rig understand KML, the look at tag is a specific instruction set that tells Google Earth position the virtual camera. So it is look at this specific position on the globe. Altitude mode set to relative to ground. This ensures that if you are looking at the mountain, the camera stay at the correct height relative to the peak, not the sea level. Next, from this LG service.fly to look at, this specifically takes the XML KML string and wrap it into a SSH command with fly to function. This command execute in Liquid Galaxy Master over network, which instantly update the view on the connected screens. This section builds the map interface and handle the timing of our command. We capture movement data silently due to a drag on camera move, and on fire only fires the network command when the map is still on, ideally ensure a smooth and professional user experience. Scaffold and center, this provide the basic structure to ensure the map is perfectly centered on the phone screen. This is all complete code logic of the map screen properly where map is placed and is synced with LG-Rig. This is the code visualization of the map screen.dart file. Here in left we have Google Map mobile app user side where user can zoom, pan or change location on the by touching the map. On camera move, when there is any interaction, the position data is here and it go to the last camera position, which gets the from this last camera position we can get the data of latitude, longitude, zoom, tilt, bearing. Zoom data is converted into range by the function zoom to range. We here you can see. Then these five parameters are used to make the look at KML tag. After making the look at KML tag, this is sent to LG service dot fly to function. The LG service fly to function is made in LG service class. We have many other functions like execute, query and different type of function that is used. After this, fly to look at SSH command is gone to the Liquid Galaxy rig where the synchronized movement observed. This is the Google Earth side and this is the user side. When so it is the complete code visualization when the user move any interaction with the map, it directly show on the Google Earth in Liquid Galaxy rig. Next, this is the UI of setting screen.dart file, which uses functions from LG service.dart file that handles the connection and set up the proper connection between mobile app and the LG rig. In conclusion, let's revise all the things what we have done till now. So the main aim of this presentation is to achieve real-time synchronization between Google Map running inside the mobile application and Google Earth running on the Liquid Galaxy rig. The app features was designed to bridge the gap between mobile map interaction and large-scale impressive geospatial visualization. Instead of treating Google Maps and Google Earth as independent systems, this works to connect them in a single synchronized environment. Through this app, any camera movement performed on mobile applications such as panning, zooming in, zooming out, changing location is instantly reflected on the Google Earth. This allows users to control large scale Google Earth visualization simply by interacting with their mobile device. From technical perspective, the project involves several important challenges. Google Map and Google Earth use different camera models, so a direct mapping was not possible. So solve this logic to convert Google Map zoom level into Google Earth camera range implemented. Additionally, secure and reliable communication was established between the app and the LG rig using SSH based control. Every time the user pans, zoom or change the map viewpoint, the camera latitude, longitude and zoom level are captured in real time. Camera updates are triggered only when the map interaction stop using camera ideal event. This ensures unnecessary network traffic and ensure smooth performance without sacrificing accuracy. The captured camera data is formatted into a KML lookat structure, and then that lookat structure is sent to LG rig using command execution function that is made in LG service class using a secure SSH connection. This allows the mobile app to send command directly from the app to the Google Earth safely. Overall, this presentation holds all information and code logic regarding the feature synchronization between Google Map in mobile app and the Google Earth in the Liquid Galaxy. Let's now end the video. Make sure to try this feature by yourself. Thank you for your time.